أهلا بيكم طالبات وطلاب جريد 1 بريب. برحب بيكم ومع بعض هنبدأ درس جديد وحلقة جديدة في الماث تحت رعاية وإشراف وزارة التربية والتعليم. درسنا النهاردة هيكون عن adding and subtracting algebraic expressions، وكمان هنتكلم فيه عن multiplying and dividing algebraic terms. So let's get started. Adding and subtracting algebraic expressions. To add and subtract algebraic expression, let's talk about our warming up first to be clear for you. Do you remember the like terms? We have the same variable with the same exponents. For example, 8x squared and 3x squared. And as you can see, we have the same x with the same exponent, which is 2. So they are like terms. And the second is about additive inverse to change the sign of each term. For example, if I have 5, the additive inverse for it is -5. And the sum of any number with its additive inverse is equal to 0. That's what I needed in today's lesson. So let's talk about adding algebraic expressions. Here we need to add the like terms. For example, add 4x squared minus 9 plus 3x and 2x squared plus 7x plus 5. So in this case, we need to underline the same terms. Here 4x squared and 2x squared. To add them, so 4 plus 2 is 6x squared. Just add the coefficients 4 and 2. The second, we are going to underline 3x and 7x. 3x plus 7x is 10x. And the last one for the constant, which is -9 and +5. Here we have integers, different signs, so put the sign of bigger, then subtract. -9 and 5. 9 is the greater number, so the sum is negative with 4. So -4. Let's watch this video to add and subtract algebraic expressions.
Students, we studied previously about multiplying and dividing algebraic terms. Now in this part we will learn about adding algebraic expression, and we should know that there are two methods for adding algebraic expressions. Click on each icon to learn about each method. We need to add the following two expressions, 7a plus 5 minus 3b, and a minus 2b minus 4. We will use first the horizontal method. To add these expressions using the horizontal method, we need to arrange the terms horizontally first as shown. Then we add the like terms together as you see, and the addition result equals 8a minus 5b plus 1. Now we will learn how to add these two expressions using the vertical method. To add these expressions by the vertical method, we are going to arrange the expressions vertically, so we make the like terms lie under each other as shown. Then we add the like terms together as you see. So the addition results will equal 8a minus 5b plus 1.
As we have seen in this video, we have two ways to add algebraic terms or algebraic expressions. We can add them by horizontal method, okay, keep them on the same line and add the like terms, or by vertical method to arrange them under each other with the same variable, as we said, with the same exponent or like terms. Now we are going to take example for it. Find the sum of 2n to the power of 3 minus 8nm plus 3 and 7n to the power of 3 plus 2nm plus 6m minus 2. I'm going to solve it by the horizontal way. We underline the same or the like terms. 2n to the power of 3 with 7n to the power of 3 equals 9n to the power of 3. Okay, now take nm. Here negative 8 nm and positive 2 nm. Sign of bigger, then subtract. Here 8, it has the bigger, or 8 is the bigger number. We are going to take the negative sign for it, so the answer is negative 6 nm. Then here we have 6m in the second expression, but in the first we don't have any m. So I'm going to write 6m as it is. Don't touch it because we cannot add it with any other term in the first expression. Then circle positive 3 and negative 2. 3 minus 2 is 1. So the answer here is 9 n to the power of 3 minus 6 nm plus 6m plus 1. Now we are going to talk about additive inverse of the algebraic expression. All we have to do to change the sign of each term. It is the additive inverse of each term in this expression. Find the additive inverse of 4x squared minus 8x plus 1. So let's change the sign of each term. The first one is 4. It's positive, so change it. Becomes negative. The second one is negative 8, so it becomes positive. And the third one is plus 1, so it's negative 1. So the additive inverse is negative 4x squared plus 8x minus 1. Remark that the sum of any algebraic expression and its additive inverse is equal to 0. Even if we have numbers, if we have terms, if we have expressions, so it's a rule. The sum of any algebraic expression and its additive inverse is equal to 0 always. Now we are going to talk about subtracting algebraic expression. Do you remember when we wrote that in integers a minus b is equal to a plus negative b? So we are going to make it as adding, but with the additive inverse for the second expression. For example, subtract 5y squared minus 3x plus 7 from 2y squared plus 4x minus 9. And here we have subtract expression from another expression, and that's what we said in the last episode. We said when you see word subtract from, just switch the order. So we are going to start from 2y squared plus 4x minus 9 minus, and you have to open brackets. Why? Because we have to change all the sign inside this bracket. So 5y squared minus 3x plus 7. Let's change it one by one. The first one, it becomes negative 5. The second one, it becomes positive 3x. The third one is negative 7. And as you can see, it's written like that. 2y squared plus 4x minus 9 minus 5y squared plus 3x minus 7. So here, by the horizontal way, I'm going to take y squared with y squared. 2y squared minus, don't forget to take the sign with it or the operation with it, minus 5y squared will give us negative 3y squared. What about 4x and 3x? You can make it as a zigzag. Okay, so here 4x plus 3x is 7x. Then the last one, negative 9 and negative 7, which is same signs, so same sign, put it as it is and add, so negative 16. That is the answer, negative 3y squared plus 7x minus 16. Now remember that we are going to write b minus a4, subtract a from b, and that's what we said it the last session. So we are going to switch the order, start from b, then subtract a from it. What else? What is the decrease of a than b? So also we have to switch the order. It's b minus a. Keep that in mind to switch the order in each one of them. And the third case is 4. What is the expression which should be added to get or added to A to get B? So also subtract, so B minus A. Okay, today in this part we are going to talk about another lesson, which is multiplying and dividing algebraic terms. Our warming up is about A to the power of M. A is called base, M is called exponent. For example, if I have 2 to the power of 4, that means we are going to repeat this 2 4 times. So 2 times 2 times 2 times 2 4 times will give us 16. Multiplying the like bases. Generally, when multiplying the like bases, add their exponents. If A is a rational number and M and N are two positive integer numbers, then when we multiply them, A to the power of M times A to the power of N equals A to the power M plus N. What do you observe? We have the same base. We have the same A. And the exponent is M for the first A, and the other one is N. So we are going to write A just one time and add M plus N. So when we multiply, add the exponent. To be fixed in your brain, the multiplication sign looks like the addition a little bit. So here, take example for it. 2 to the power of 4 times 2 to the power of 6. We are going to keep the same base, which is 2, and add 4 plus 6. So 4 plus 6 is 10. 2 to the power of 10. And don't say 20, because 2 to the power of 10 means I'm going to repeat this 2 times itself 10 times, okay? Now dividing the like bases. Generally, when dividing the like bases, subtract their exponents if A is a rational number not equal to 0. M and N are two positive integer numbers where M is greater than or equal to N, then A to the power of M divided by A to the power of N equals A to the power of M minus N. So in division, we are going to keep the same term, the same base as it is, but subtract the exponents, so M minus N. And also to be fixed in your brain, the division sign looks like the subtraction when you cross out the two dots. So in division, we are going to subtract the exponents. Take an example for it. 5 to the power of 6 divided by 5 to the power of 4. We are going to write 5 and subtract. Here we have 6 minus 4, which is 2. By the way, we can write it as division sign, or we can write it as a fraction. Do you see 5 to the power of 6 is at the top as numerator, and 5 to the power of 4 is at the bottom as denominator, so we will subtract 6 minus 4. But we have a condition in the definition. Let's read it one more time. A is a rational number not equal to 0. Why we put this condition, not equal to 0? Because when we divide any number by 0, we will get undefined amount, okay? So here always the denominator, or do you remember dividend, divisor, and quotient? The second one is divisor, okay? So we can say it as the divisor or the denominator should be not equal to 0. Now multiplying and dividing algebraic terms. To multiply or divide, we are going to multiply or divide coefficient using the signs rule. Do you remember the sign rules? Do you remember the Chinese face? When I have negative times negative will give us positive, and so on. So for example, find the product of 2a to the power of 4b and negative 7ab to the power of 3. Product means what? When I ask you find the product, that means you have to multiply them. Okay, so we need to multiply them. Let me revise. Product means multiply, sum means add, difference means subtract, and quotient means divide. So we are gonna multiply them. And as we said, we are gonna multiply the coefficients. 2 times negative 7, which is negative 14, and a to the power of 4 times a. This a, what is the exponent of it? It doesn't have an exponent. So the exponent is 1. It's not written, but we know that from the last session. So if I have any variable without an exponent, that means it's to the power of 1. So I'm going to write it here, 1. So I'm going to add 4 plus 1 is 5. So it's a to the power of 5. What about b? The first b is to the power of 1. The second b is to the power of 3. So 1 plus 3 is 4. So the final answer is negative 14, a to the power of 5, b to the power of 4. Now find the quotient of negative 20 x to the power of 4, y to the power of 7 by 5x to the power of 3, y to the power of 2. Do you remember what do we have to do? In division, we are going to divide the coefficient and subtract the exponent for the same variable, the same term. Here we have this one. Let me clear. Negative 20 divide by 5. Here, that's our Chinese face. Negative divide by positive is negative, so it's negative 4. X to the power of 4 divide by x to the power of 3. 4 minus 3 is 1. So it's x to the power of 1, which is x. And what about y? Y to the power of 7 and y to the power of 2. So 7 minus 2 is 5. So the final answer is negative 4x and y to the power of 5. Now let's take more practice on the whiteboard to be clear for you. Here we have practice. Find the missing number. Number 1, 35 a to the power of 7 divided by what equals 7a to the power of 4. Okay, do you remember the first one is called the dividend? The second is called divisor, then quotient. So here 35 divided by what to give us 7? 35 divided by 5. Okay, what about a? We start from a to the power of 7 and we got a to the power of 4. So ask yourself, a to the power of what? When I subtract it from 7, we will get 4. So it's to the power of 3. Okay, to be sure, 35 divided by 5 is 7. Yes, of course. A to the power of 7 divided by a to the power of 3. We are going to subtract the exponent. So 7 minus 3 is 4. So the answer is correct. The second one. 40x to the power of 4, y to the power of 9 equals 5x y to the power of 3 times what? So here we have, I need another factor here. I'm going to start with 5. How can we convert this 5 to be 40? 5 times what is 40? 5 times 8. Then this x, it doesn't have an exponent. That means x to the power of 1. So 1 plus what is 4? When we multiply, add the exponents. So x to the power of 1 times x to the power of 3. How do we know? Because 1 plus 3 is 4. Now try yourself in y. Y to the power of what? Here the answer is 9 and the first factor is y to the power of 3. So 3 plus what is 9? 3 plus 6. Take care, don't write y to the power of 3. When we multiply, we will add the exponents, not multiply them. So the final answer is 8. Because 5 times 8 is 40, x to the power of 3, because 3 plus 1 is 4, y to the power of 6, because 6 plus 3 is 9. Let's take another one. Here I have a fraction, 24a to the power of 6, b to the power of 3, c to the power of 5. Divide or over, and as we said, over means divide, so negative 8a to the power of 6, b to the power of 3, c to the power of 2. Let's divide. The coefficients first, 24 divided by negative 8, the Chinese face. In multiplication and division. So 24 is positive, divide by negative, so positive, divide by negative, the third sign is negative. 24 divided by 8 is 3. We finished from the coefficients. Now, a to the power of 6 divided by a to the power of 6. Any number divided by itself equals 1. So we are going to cross a to the power of 6. Will give us 1. What about b? b to the power of 3 over b to the power of 3, also 1. If we have the same number, if we have the same variable with the same exponent, will give us 1. What about c? c to the power of 5 over c to the power of 2. So we are going to write c and subtract here 5 minus 2. So the final answer is negative 3 c to the power of 3, because 5 minus 2 is 3. What about if I need to apply the rule here, for example, b to the power of 3 minus 3? Also, we will get b to the power of 0, and as we said before, any number to the power of 0 equals 1. So immediately cross the same variable with the same exponent up and down, no need to subtract, because I have b to the power of 3 over b to the power of 3, cancel them with each other. So the quotient is negative 3 c to the power of 3. More practice. If we have 10 y to the power of 7 n to the power of 3, divide by 5y n to the power of 2. What do we have to do? Think about it with me. The coefficient first, 10 divided by 5. 10 divided by 5 is 2. In coefficients, we are going to divide them, but in the same variable with the same here variable, this y is to the power of 2, we are going to subtract the exponent. So y to the power of 7 divided by y to the power of 1 is y to the power 7 minus 1, which is 6. Now what about n? n to the power of 3 divided by n to the power of 2. So it's n 3 minus 2, which is n to the power of 1. And no need to write it to the power of 1, so it's equal to n. So the final answer, or the quotient, is 2y to the power of 6 times n. So let's make our brief summary for today's lesson. We are going to, we talked about the adding and subtracting algebraic expressions, and we said we have to add and subtract the coefficients for the like terms. In multiplying and dividing terms, we are gonna divide or multiply the coefficients, but in the exponent we are gonna add when we multiply, we are gonna divide when we subtract the like term. That's all about it. Thank you so much. I hope it was clear for all of you. Bye bye.